In this video series, we will be reviewing the process of creating a custom checkmate probe to use with the checkmate programming module. The basic workflow consists of 3 steps. First, create a 3D assembly model of the probe in SOLIDWORKS. Then second, using the Probe Builder 2 add-on, we add the checkmate probe properties to that probe model. And finally, step 3 is to save the finished probe to a checkmate PRB probe file. In this video, we will be reviewing step 3. Now, we're going to save this probe model with all of the checkmate probe properties that we've added to a PRB probe file. I'm going to make my checkmate window smaller and bring up my Windows Explorer that's already opened to the probes folder in the public documents area. I have the files in here sorted by date, so you will be able to see the new PRB file as it's created. Still, on the Probe Builder 2 tab, we select Save to PRB file. And there is our new PRB file. That finishes the process of creating a ProbeRack PRB file. Let's open an SLDPRT file and load in our new probe. Let's look at the group list to look at our rack configuration. When we loaded our PRB probe rack, 3 probe groups got loaded. Notice the C number at the end of the group name. The probe without a C number is rack configuration 1. The probe with a C2 is rack configuration 2. And the probe with a C3 is rack configuration 3. We will use these C numbers next. Let's go and edit the AB angles. You can see that there are no angles at all in this PRB file. Even if I have an INI file of probe angles to use, I still like my probe to be loaded with the first position of A0 and B0. Our first position 1 will be A0B0 with a tip number of 1. We leave the configuration field blank, signifying that this is the buildup from rack position 1. I'm going to skip a few positions in case we want to add more to the probe in rack 1. We will start rack 2 at a higher number, let's say 10, with A0, B0, a tip number of 1, and we'll put C2 in the configuration field, signifying that this is the buildup from rack position 2. Now for the star probe that was in rack position 3. If you recall, we had 4 tips that would be at 0, 0. Let's start at position 20 and add all 4 tips. We don't have a straight down tip, which would normally be tip 1, so we will start with tip 2, the tip that points to the right. And of course, the configuration field will be C3. We'll add the next tip, A0B0 tip 3, still with the C3 configuration, and that will be checkmate position 21. Position 22 will be tip 4, and position 23 will be tip 5. Now that we have added some basic A0B0 tips, let's resave the PRB file so we'll have them for next time. So let's do some probe rotations and a couple measurements so we can admire our work. I'm going to switch to the special views and then put a work plane above the part. I'm going to insert a probe rotation behind the part, selecting the probe from rack 1. Now I'm just going to put a surface measurement on top of the part. Now I'm going to add another probe rotation behind the part, selecting the probe from rack 2. I'm going to put another surface measurement on top of the part. Now I'm going to add the last probe rotation behind the part to the left, selecting probe tip 2 from rack 3. And a final surface measurement on the left side of the part. Let's do a simulation and watch all three probe configurations in action. Starts with the probe in rack 1, then uses it to take a measurement. Switches to the probe in rack 2, then uses it to take a measurement. Switches to tip 2 of the star probe in rack 3, and uses it to take the measurement on the side of the part. Let's have some more fun and try using our probe rack using Checkmate's automation tools. I'm going to open a new program folder, or what we call a segment, and I'm going to put some more surface measurements all around the part. This time I'm not going to worry about changing probes or adding probe moves. We'll let Checkmate figure that out for us. First, we'll do accessibility analysis so Checkmate can analyze which probe racks are the best to use for each measurement. Now, let's have Checkmate automatically add probe moves and rotations or rack changes, finishing up with collision detection. Let's do a simulation and watch all three probe configurations in action. Ah, beautiful! This concludes our video series of using the Checkmate Probe Builder 2 to generate a Checkmate probe rack.